Hello everyone, welcome to the world of software testing. So in the last lecture, we have covered the understanding of waterfall model in detail along with its advantages and disadvantages. So in this lecture, we are going to discuss about the understanding of the V model, advantages and disadvantages of V model, and when to use the V model. So basically, V model is nothing but a VV model, or is also called as verification and validation model. So let's discuss in detail. So the VV model or a V model or a verification and validation model. So V model is also called as the VV model or verification and validation model. V model is basically an extension to the waterfall model, and in this model each testing phase is associated with the corresponding development phase. So for every development phase has its associated testing phase. It's a mapping between development and the testing stage. So in V model of SDLC, the execution of processes happens in a sequential manner, and that in the V shape. Means on one side of the V there is a development phase, that is a verification, and on the other side there is a validation phase, that is the testing phase. So let's understand with the V model diagrammatic representation. So you can see here, this is a pictorial representation of the V model, and you can see on one side there is a verification phase, and on the other side there is a validation phase. So in the verification phase you can see BRS, SRS, HLD, LLD, coding, and on the other hand there are different types of testings: unit testing, component testing, system integration testing, system testing, and acceptance testing. So each and every development phase is associated with the testing phase. So each of the development phase have its related testing phase. So in a V model, every phase will start only after the completion of previous phase. So again, as we saw in case of waterfall model, the same logic applies here as well. Every new phase will start only after the completion of previous phase. So what is verification and validation? So verification checks whether we are building the right product. So this is we can say the preventive measure. And in case of validation checks whether we build the product right. So let's understand the complete process of the V model. So again, the first phase is BRS, that is a business requirement gathering and the requirement analysis. So this is the first phase in the V model. So in this phase, all the product requirements or the expectations from the client side are understood from the client's perspective. This phase involves detailed communication with the customer to understand his expectation and the exact requirement. So generally, the business analyst of the organization gathers all such requirements from the client side and prepares the business requirement document, including all the requirements. So basically, this is required to gather each and every information from the client, as the most of the client are unsure about their final requirements. So we should gather each and every requirement from the client perspective, and we should not miss anything. Acceptance test design planning is done in this phase, which act as an input to the user acceptance testing. So there is a acceptance test design plan will be there based upon the BRS, and that will act as an input to the acceptance testing, which is the associated testing for the BRS, that is the business requirement specifications. Then there is a next phase, that is the SDLC phase of the SDLC, that is the system design. So the overall requirements are clear, means once all the product requirements are clear, the system design will take place, which includes the complete detailing and understanding of the hardware and communication setup for the product which is under the development. So SRS documents will be prepared, which includes the complete requirements, expectations related to the functional and non-functional criteria. The system test plan is prepared based on the system design. This will act as an input to the system testing. So here, if you see, this is the system test plan which act as an input to the system testing. And here, this is the acceptance test plan will be prepared, which act as an input to the acceptance testing based upon the business requirement specifications. Then there is a design phase. So in the design phase, the system and the software design documents are prepared by the system architects, the senior developers, to get the overall system architecture. So with the SDLC, every phase prior to the phase act as an input to the current phase. So in this phase, so you can see this is the design phase. This is the design phase. So first one is the HLD, this is high level design, or also called as the architectural design. And the second one is the LLD, that is a low level design, or also called as the module design. So let's see the HLD, the high level design. So it is overall system design, and it describes the relationship between the modules and the functions of the system. It also includes the interface relationship and the dependencies between the modules. So as a software, there are a lot of modules inside it. So basically the HLD represents the relationship between the interfaces and dependencies between those different modules. The baseline in selecting the architecture is that it should understand all, which typically consist of all the requirements, which typically consist of list of modules, the brief functionalities of the each module, their interface relationships, dependencies, database tables, architectural diagrams, technology details, and many more things. The integration testing model is carried out in a particular phase. So this is the HLD. So here basically the integration planning will be done. So which act as an input to the system integration testing. Then the next phase is that is the LLD in the design phase. It is also called as the module design as well. So the LLD is nothing but a detailing the HLD. So it defines the actual functional logic for each and every component of the system. So whatever the design we have done in the high level design, so we are just doing the detailing of that in the LLD. The complete details on the interfaces. So in the module design phase, the system breaks down into small modules. The detailed design of the modules is specified, which is known as the low level design. So this is the design phase. Let's move on to the next phase, that is the coding part, that is a coding phase. So in the coding phase, the actual software development starts with a coding using the defined programming language based upon the technical design document. The coding is the longest phase of the SDLC process, and the tasks are divided into small modules, units, and assigned to each of the developers. So once the coding team will complete their development for the particular release, and they will create the build, and before creating the build, before passing that build to the testing team, the developers will perform the validation of the code through the unit testing. So here, let's say we are in the coding phase now. So this is the coding. So before passing this build to the testing team, there will be a unit testing will done. So the unit testing will be performed by the developers to validate their code. If there are any mismatch in the codes, that will be validated by the developers. Then the next phase is the validation phase. So once the unit testing is ready, we can pass this build to the testing, that is the test engineers, for the testing purpose. So let's understand first what is unit testing actually. The unit tests are designed in the low level design or model design phase, and that are executed on the code during this validation phase. The unit testing is a testing at a code level and helps to eliminate bugs at the early stage. So let's say if the code having some mismatches, that will be eliminated right at the point before the build is passed to the testing team itself. So unit testing is a testing at a code level and helps eliminate bugs at the early stage. Though all the defects cannot be uncovered by unit testing basically carry out by the developers. So the unit testing is performed by the developer specifically. Once the unit testing is carried out by the developers on the application and on the application is completed, that will be passed to the testing team in terms of build or URL, and the build is deployed to the testing environment. So once the build is deployed to the testing environment, the test engineer starts performing the various types of testing, the functional as well as non-functional testing, by executing the designed test cases. So again, as we have discussed in the waterfall model, so in parallel with the coding, the test engineers will start identifying all the possible test scenarios, and based on those scenarios, they will write the test cases to test those functionalities or the features in the application. And once they get the build from the developers, they can right away start the testing. So they will perform the functional as well as non-functional testing by executing those designed test cases. So once they get the build from the developer side, they will first start the component testing. So again, for the component testing, they will take the input from the low level design. The component testing is performed on each individual component separately without integrating with other components. So let's say, for example, the application have several module and they have different dependency. They have some integration. So in the component testing, we need to we as a tester need to test all those modules separately without integrating with the other components. So it's also referred to as a module testing when it is viewed from the architecture perspective. The component testing is also referred to as a unit testing, program testing, or a module testing. So sometimes we also call it as unit testing, program testing, or the module testing. Then the next is the system integration testing. So this basically tests the application with respect to the HLD, that is high level design, with the integrated modules. So system integration testing is associated with the architectural design phase or the high level design phase. The integration tests are performed to test the coexistence and communication of the internal modules within the system. The system testing is directly associated with the system design phase. System tests check the entire system functionality and the communication of the system under the development with the external systems. So this is for the system testing as well. So in the system integration testing, what we do is we integrate all the components, all the modules, and we test the system. We test the application as an integrated one with the system integrated testing. And then there is a system testing in which we check all the overall functionalities of the application. So system tests check the entire system functionality and the communication of the system under the development with the external systems. Most of the software and hardware compatibility issues can be uncovered during the system test execution. It checks all the functional and non-functional requirements mentioned in the SRS document. The system testing focus on the below aspects. So some of the aspects such as the user interface testing, will be comes under the system testing, the functional testing, non-functional testing, and the usability testing. All we are going to cover in the upcoming lectures. So once the system testing is completed, the final one, that is the acceptance testing. So it is also called as the user acceptance testing or the customer acceptance testing. So there is a client involvement in the UAT. It is also called as UAT. There is a client involvement, and the senior testers and developers will give demo of the functionalities to the client. The client will compare the demo of the actual application to the requirement and expectation mentioned in the BRS document. So as we know, the acceptance testing refers to this business requirement specification. He compares the actual application to the requirement or expectation mentioned in the BRS document. So this involves the testing of the product in the user environment. So there will be a user environment. The acceptance test uncover the compatibility issues with the other systems available in the user environment. So till this, we are using some kind of SIT environment. Then here comes the UAT environment. So this is basically a replica of the user environment, that is a production environment. It also discovers the non-functional issues such as load and performance defects in the actual user environment. So this is basically a acceptance testing. So this is the overall process of the V model. So V model is nothing but a VV model or verification and validation model. So on the left hand side you can see the verification part, and on the right hand side there is a validation part, and each of these phases are corresponding to the or associated with the testing phase. So each and every phase, every development phase involves these testing activities. So that's it for the V model process. Let's understand some of the advantages of the V model. So the first advantage is testing is in the every phase. So each of the development phase has its corresponding testing phase. So testing is in the every phase. It is simple and easy to use. It is highly disciplined model, and the phases are completed one at a time. Then testing activities like planning, test designing happens well before coding, and this saves a lot of time in the planning. Then the next is proactive defect tracking. So the defects that are found at the early stages, because we have testing in every phase. Then easy to manage due to the rigidity of the model, and each phase has specific deliverables and a review process. Works well when the requirements are very well known, documented, clear and fixed. So these are some of the advantages of the V model. Then let's discuss about some of the disadvantages of the V model. So again, similar to the waterfall model, we have more documentation in case of V model as well. The initial investment is more, as all the people needs to be hired earlier, because the testing, if you consider for the testing will start right from the start. Then the software is developed during the implementation phase, so no prototype of the software are produced. The requirement documents has to be updated if there will be changes in the requirement. So if any changes happen in midway, then in that case the test documents along with the requirement document has to be updated. So this is little bit time consuming. Then poor model for long and ongoing projects. So these are some of the disadvantages of the V model. And now let's discuss about when to use the V model. So for small to medium sized projects where the requirements are clearly defined and fixed, in that case we can use the V model. The V model should be chosen when ample technical resources are available with the needed technical expertise, and again where the project duration is short, there we can use the V model, and the requirement should not be ambiguous, so that should be clear. and fixed. These are the reasons where we can use the V model. So thank you so much for watching this video. Please do subscribe our channel World of Software Testing for such more videos. Also click on the bell icon to get the latest updates. Thank you so much for watching.